Hey everyone! You know calculus में एक topic है maxima and minima, and I know its name can sound a little scary, right? But what if I told you it's just a cool way of finding the highest peaks and the lowest valleys in any situation? Today, we're going to break this whole concept down and make it super simple. Let's get started.
Okay, just imagine this. You upload a YouTube video and bam, it goes viral. The views shoot up, then dip a little, then go up again. Now, in that whole journey, how would you find the exact moment when the views were at their absolute highest, that single peak moment? Well, that is the core idea behind finding a maximum. All right, so let's stick with this viral video idea, okay? We're going to use its views graph as our case study, and through this, we'll understand all the key concepts of maxima and minima. You know, the journey of a viral video is never just a straight line up, right? As you can see in this graph, there are lots of moments where the views peaked and then came down. Each of these small peaks is what we call a local maximum, and every dip or valley in between them, that's a local minimum. Okay, now look, the textbook definition, it can seem a little technical, but in simple words, a local maximum is just a point that's higher than all the points immediately around it, in its immediate neighborhood. Think of it like this. It's the king of its own small area.
And it's the exact same logic for a point of local minima. It's simply the lowest point when you compare it to its immediate neighbors. It's the bottom of a valley in its local area. Simple as that.
So we can see these peaks and valleys on the graph. That's easy. But how do we find them with math, right? This is where we put on our detective hats. To find the exact location of any maximum or minimum, we first need to find some critical clues. Take a really close look at the graph. Whenever the curve hits the very top of a peak or the very bottom of a valley, just for that one split second, it becomes completely flat. For that single moment, the rate of change is zero. And we all know, a totally flat, horizontal line, what's its slope? It's always zero. And this, my friends, is our biggest clue in this investigation. And in calculus, we have a super powerful tool to find the slope at any point on a curve, right? And what's that called? It's the first derivative, which we write as f prime of x. So if the slope at the peak is zero, it just means that at that point the first derivative, f prime of x, must be equal to zero. Boom! We found our main clue.
So these special points where f prime of c is zero, they have a name. We call them critical points. You can think of them as our main suspects. If a maximum or minimum exists, it's going to be at one of these spots.
All right, so we found our suspects. These are the critical points where a maximum or minimum could be hiding. But how do we confirm it? Well, for that, our detective kit has two special tests we can use. The first method is the first derivative test. This test looks at the sign of f prime of x just before and just after our critical point c. Think about it with our video. If the sign changes from positive to negative, it means the views were going up. That's the positive slope. And then they started going down, the negative slope. What does that create? A peak. So that's a local maximum. And if the sign changes from negative to positive, it means the views were falling and then started rising again, creating a valley. That's a local minimum. Now, the first derivative test works every single time. But let's be honest, sometimes it's a bit of a long route. Luckily, there's a shortcut, a much faster way to get the answer, and that's the second derivative test. In this test, we first find our critical point using f prime of c equals 0. Then, we find the second derivative, f double prime of x, and plug in our point c. Now here's the cool trick to remember this. If f double prime of c is negative, less than 0, think of a negative mood, a sad face. A sad face looks like a peak, right? So it's a local maximum. And if f double prime of c is positive, think of a positive mood, a happy face. A happy face looks like a valley. So it's a local minimum. See? Super easy to remember. Okay, listen up. This is super important. You have to remember this. What happens if f double prime c equals 0? Well, in that case, the test fails. It's inconclusive. It tells you nothing. In that situation, you have no choice. You must go back and use the good old first derivative test. So many students mess this up, so don't be one of them. All right, so far we've been talking about local maxima, right? The kings of their own little neighborhood. But what if we want to find the ultimate record for our viral video? Like, what was the absolute highest number of views it got in the first week? For that, we need to understand a new concept, absolute maxima.
So here's the difference. The local maximum was the king of its neighborhood. But the absolute maximum, that's the king of the entire kingdom, the one single highest point in the whole interval we're looking at.
And finding this is actually a really straightforward step-by-step process. Ready? Step 1, find all the critical points inside your interval. Step 2, and this is the part everyone forgets, add the endpoints of the interval, A and B, to your list of candidates. Why? Because the highest or lowest point could be right at the very beginning or the very end. Step 3, take all these points, the critical points and the endpoints, and calculate the function's value for each one. And finally, step 4, just compare all the values. The biggest one is your absolute maximum, and the smallest one, that's your absolute minimum. That's it. Whew! Okay, that was a lot, but we've covered all the main ideas. Let's do a super quick recap of our detective game plan.
So here's the game plan, nice and simple. Your goal, find the peaks and valleys. Your clues, the critical points, which you find by setting the first derivative, f prime of x, to 0. Your tools for confirmation, the first and second derivative tests. And the ultimate prize, the absolute maximum. To find that, you always have to check the endpoints of the interval too. Got it?
So the next time you see a graph, maybe it's for the stock market or your stats in a video game or anything really, can you spot the peaks and the valleys? Of course you can, because now you don't just see them, you have the mathematical tools to find them and prove they're there.